magnesium phosphate. Magnesium phosphate. Magnesium, we've worked with one before, has the charge of Mg 2+. Phosphate, if you look back on the other page, is the species PO4 3-. Again, we have to balance the charges. It's an ionic compound. So whether you're using the crisscross method or the mathematical method, this 2 tells me that I'm going to need 2, and kids want to put it right inside the parentheses. You don't. You keep going, and it comes down and outside of the parentheses, just down there. So I don't need 2 more sets of oxygen or 2 more sets of phosphorus. I need 2 more sets of phosphate, and this whole thing, PO4 3-, is a phosphate ion. With that said, then, I also need 3 sets of something that's 2+. So I'm going to put my 3 down here. And I'll carry the charge again. And if we look at the mathematics behind that, Mg 3 parentheses PO4 2. Now, where does this go to? The 3 tells me I have 3 magnesium. That 3 only goes to the magnesium. The subscript 2 only goes and describes the species that's in parentheses. So this 2 is only referring to the phosphates. It doesn't go all the way back through, all the way over to the magnesium. Balancing the charges to make sure everything is coming out to 0. I have 3 things that are 2 positive for a +6 charge. That means the magnesium, each magnesium has lost 2 electrons. So I needed 3 of those. Each set of phosphate has to gain 3. I need 2 of those. Sorry. Two sets of -3 is -6. +6 plus -6 comes out to be 0, which is what we want. So the formula for magnesium phosphate is Mg3 PO4 2. That's magnesium phosphate. Aluminum nitrate. Aluminum 3+. Nitrate is NO3, the whole thing, 1-. If I use the crisscross method, I'm going to need 1 thing, 1 species that's 3+. That 1 came down. I'm going to need 3 species 1-. So my formula for aluminum nitrate comes out to Al NO3 3. Notice I didn't write the 1 next to the aluminum because it's understood that aluminum is written there. Now, how many things do I have here? I would have 1 aluminum atom. This 3 multiplies the nitrogen, so I'd have 3 nitrogen atoms. And I would have 9 oxygen atoms. Eventually we'll have to do this when we balance equations, balance reactions. That 3 is really just distributed only to the nitrate ion. This last example I use as an example of what happens if we don't put parentheses, if we use parentheses incorrectly. Magnesium is a 2+ charge. The hydroxide beast is OH, 1 negative, and oftentimes you do not see this in parentheses. Just out there sitting freely. If I were to write this like this, Mg, and we know that the 2's got to come down outside of here because I need 2 hydroxides. But oftentimes students will make this mistake. They'll write MgOH2. Well, that's not right because I don't have 2 hydroxides then. I only have 2 hydrogen, and I don't have 2 oxygen. I would have 1 magnesium, 1 oxygen, and 2 hydrogen, and that's not what we need. That's an incorrect way to write that. To correctly write it, I need 2 things. So we'll make a lightning bolt. I need 2 things that are -1. And I need 1 thing, 1 item, 1 species that's +2. And so it's very important that when you're writing this that you put the hydroxide in parentheses. Mg, I only need 1 of those. OH2, because it's that whole species of hydroxide that is a -1, I need to make sure that that 2 is distributed for the entire hydroxide. And just to be complete, magnesium's a 2+. I have 1 of them. That's +2. Hydroxide is a -1. I have 2 of them. 2 times -1 is -2. And you can see that we balanced the charges nicely. And that's how you work with polyatomic ions.